Continuing with section 4.4, we are now looking at this example where f of t is equal to sine of t. And as from before, what we have learned, probably a times sine t would be a good guess for the particular solution. So we start with that. This is our first guess. Y is equal to a sine t. We find the first derivative and then we find the second derivative. Now note here in the first derivative we have a cosine term. So it means this might not be a good idea, our first guess. But let us go keep going, and then we notice after taking the first and the second derivative, we plug in the equation and then we compare the coefficients. So we are comparing the coefficients of sine t on both sides and comparing the coefficients of cosine t on both sides. So from this equation, you notice that there is cosine t only on the left side, and there is sine t on both sides. So if you compare the coefficients of cosine, it will be 3a is equal to 0 because there is no coefficient on the right, so it's 0. So 3a is equal to 0, which will give us a is equal to 0. And when we compare the coefficient of sine t, we get a is equal to 1. So this is the issue because we cannot determine which value a has. So we say that this is not a good guess. So our second guess would be y is equal to a times sine t plus b times cosine t. Now notice here, if you wrote it like a times cosine t plus b times sine t, that is fine. Just remember that what you need to do is have both terms in there, sine t and cosine t being added, and the letter you put in front of them doesn't matter. It will come out. No, name doesn't matter here. Value will be correct if your algebra is correct. So take the derivative, plug in, compare coefficients. Now we get two equations. I gave them over here. Where did it go? So here are the two equations. And then from one equation, first equation, I wrote that a is equal to 1 plus 3b. And we will plug this in the second equation. So I'm doing the substitution method. You can do the elimination method, or you can even do it by using the matrices. So it will be like 1 minus 3, then 3, 1 matrix, and we will adjoin with it the matrix or the vector 1, 0. And then apply the row operations. So, or do the echelon form or the reduced echelon form, whichever. So whatever method you choose, you can use here. Anyhow, so it gives us b is equal to negative 3/10, and then a will be a is equal to 1/10. So the particular solution is what I have here. So this is the particular solution. So now it gives you an idea of how to pick your particular guess. Well, you won't be guessing all the time now. You will actually should have an idea of what it should look like. And here is some, kind of an idea of how to think. So this is a list of the functions on the right side of the differential equation, and then on the right here is the guesses. So if you have an exponential function, then you will have the exponential function over there with the unknown, undetermined coefficient, which you have to determine. Then if you have just a cosine term, you will have cosine and sine both in the guess. It's just a sine term, you'll have both in the guess. in the particular solution, I should say. If you have both in the function, you will have both in the particular function. If you have a polynomial, you have the, or if you have a term like a power function, or the highest degree term, whatever the degree of that term is, you have to have the polynomial of that degree, the whole polynomial, not just the highest term. So for example, if you have t square e to the t, then this is your f of t, then your yp should be a t squared plus bt plus c times e to the t. Now you might say, okay, I understand that if we just had a t squared, if our f of t was just t squared, it would be, our guess would be a t squared plus bt plus c. That's what we have here. But what about et? Because if we had et, our guess would be a times et. So why are we not putting like a constant over here? The thing is, even if you put the constant, for example, if you said det, if you say that, we will put det. So then what is happening now, you are creating an extra more work for yourself by putting another unknown thing to be determined. We assume that the constant here got multiplied with the coefficients of this term or expression, and a, b, c are containing that coefficient of that was supposed to be with e to the t. So we will not put the d. This will reduce our work. Okay, so let's do the questions and we'll see how it goes. Next example. So we have find a particular solution to y double prime plus 4y equal to 5t squared e to the t. So as I just mentioned, so we will take y to be a t squared plus bt plus c times e to the t. First derivative, second derivative, you have to be careful now. The derivative involves product rule. So when you have a product, then you take the first derivative, you get two terms because of the product rule. But when you differentiate next derivative and you take the first derivative, you already have two terms which are products of two functions. So now you have four terms. So two from product of the first, two from product of the second. And then you can plug in. So here I have two terms by taking the derivative of y, I got one term here, one term here. And then when I take the second derivative, so I have 1, 2, 3, 4 terms, as I just mentioned. Then combine the terms such that you can compare the coefficient. So I am trying to combine the terms which have, e to the t is with every term. So that's why I have it factored out here. And then I am writing all the terms, which are left. And then in the next step, e to the t stays outside. But now I am putting the like terms together. So the t squares come together. So we have a t square term over here. And then we have a t square term over here. So this, but remember there is a 4 outside. So when you write, be careful, 4a. So that's what we get in the next step. So from the first piece, I have a, so at squared, and then we have 4at squared. And there is no other t squared term. So then we go to next one, which is the t term. So we combine all the terms which have t, or put all the terms with t together. So we have bt, 2at, then we have another 2at, and then we have we don't have any in here, but in the next one we have bt. So I have now bt plus 2at plus 2at plus, now I have combined this one. Okay, so we have 4bt from here. Okay, the 4bt term is coming from here. And then we have the constants. So that the expressions which do not have a t term with them. So all of the constants, I put them here. And then we say equal to 5t square e to the t. Now, like simplifying, combining like terms. For example, this 2at becomes 4at, and separating the terms of t square, t, and then constant. And now we will compare those coefficients, the terms, coefficients of t square e to the t, t e to the t, and just e to the t. So we get 3 equations, and remember, if you notice, we have 3 unknowns. So however many unknowns or however many coefficients you have, you must get the same number of equations. And if the system of equations is consistent, it means your guess is correct and you can proceed. If you get an inconsistent system of equations, it means your guess is not correct, or either you are picking a wrong function to use this undeterminate coefficient method, because this method is restricted to these type of functions that are given in this list. Anyhow, so comparing coefficients, doing the work, we nicely get the values of each. A is 1, B is negative 5 over 4 over 5, C is negative 2 over 25. So we go y of B is equal to t square minus 4 over 5t minus 2 over 25 e to the t. So that's our, okay. I'll stop here, do the next example in the next video.